Oh, Joy is out.
Joy just disconnected. She said
Yeah,
she's having internet problem.
yeah. I don't know. This morning also I have like,
Yeah, me too. Like earlier in the morning, like I was trying to connect to the Zoom to your class, but
cannot
uh,
also.
it didn't. Yeah, it couldn't open until I use a hotspot from my phone.
Oh, this is problematic. So hopefully next semester we will have already the real class. I don't know. So once you have done this, okay, the solver, right? So minimize the objective, which is the sum product of flow and cost. Then you can uh, get this result. Okay. And then you can go to the next one. Oh, the next one is telling what will happen if you change the initial value, okay, of the flow to 1. Okay, so for example, if I put all the flow to 1 in the initial value instead of 0, okay, then you see we have a trouble. Oh, right? Can you see that? Solver cannot find the solution. So initial value matters. So, so if you put 0, you get the correct answer, which you can compare with the manual computation. Right? Find the solution, right? There, that is the solution, which is correct. But once you change the initial value to 1, all 1, okay, cannot find the solution. So just in case you face similar problem, okay, oh, you cannot find the solution, right? So you try different initial value. That's the suggestion here. Okay. So if you have done this, okay, then you can change the origin and destination. Okay. Instead of 4, 1, now you can change to 1, 5. Okay. And I provide you with the manual computation, how to compute. Okay, we will discuss this next semester. But in here, you need to set up initial flow is all 1. So otherwise, it will not work. If you set 0, it will not work. Okay. So Excel solver is actually very sensitive to the initial values. Yeah. As I explained last time, so they are actually local optima. Okay. The way Excel work is based on Newton-Raphson method, similar. That's called conjugate gradient. What's the name? Yeah. I think Excel is telling the name. Oh, there. The name is GLG nonlinear. So GLG nonlinear is basically similar to Newton-Raphson. We discussed Newton-Raphson, remember? Okay. Okay. So yeah, that's it. So once you make this, we can go to the next topic. But can you share your screen once you finish?
Yes, sir, I can. So here it is.
Wow. Okay.
Oh wait, I will just share my whole screen. So yeah, so this is pretty much the same as yours. So
Okay.
the software is all of this has to be binary, and
Okay.
this has to this one has to be
Must be
equal to
the
this
same
one.
as that one. Yeah.
Yeah,
Okay.
this is.
Okay. Very good. And it works.
Mm. So what is the difference between GRG nonlinear
Okay. Good
and
question. So
evolutionary or
these are
simplex?
the three different method of optimization that Excel employ. Okay. There are actually different method of optimization. Not only that three, okay, there are hundreds of them, including, for example, So evolutionary is basically genetic algorithm. Simplex, you know already, the matrix simplex.
Oh yeah.
Okay, CRG nonlinear is basically Newton-Raphson. Okay. More sophisticated method of Newton, because the one that I teach you, Newton-Raphson, is only one dimension, right? This is like conjugate gradient, which is more dimension. Okay.
Mm.
So there are many method of optimization. Okay, basically, the old version is we call this classical method is using calculus. So we use what is called Lagrange multiplier. Search in Google, Lagrange multiplier.
We actually learned it last year.
Oh,
Last
you
yeah.
already learned that. Okay, okay,
Yeah.
good, good. The latest new method is using meta heuristic. Okay, you type in Google also meta heuristic. That include tabu search, PSO, okay, uncolony, particle swarm optimization, uncolony optimization, and so on. Okay, so many different new method that uh, has been proposed for the engine. Yeah, this is like the engine of how to solve, right? Of course, each method have positive and negative benefit and disbenefit. Okay. Uh, so if you want to use exact value, okay, I think GLG nonlinear is the best. Right? If this is for linear programming only, then you use simplex. Right? But if both cannot be solved using nonlinear and simplex, you can still use evolutionary. The problem with evolutionary is the result is not exact because they are using random number, right?
Mm.
The 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 result is not really exact. Unlike nonlinear, it's kind of close to exact, right?
Okay.
Okay, and evolutionary is also longer to run. You try last time.
Mm.
Yeah, take some time to run. Okay, but this is very general that you can actually solve many different problems that cannot be solved using the usual gradient method. Yeah.
Mm.
Okay.
So we can actually solve this using evolutionary as
Of
well.
course, you can try. Simplex cannot unless this is linear program. Oh, this is linear program problem. So yes, you can also use simplex. Okay. If it is non-linear, you cannot use. Using evolutionary, you see this is quite still 60%, very long to
Yeah.
build.
Yeah, I think
Yeah, you can see.
incumbent is a problem. Yeah,
Yeah, yeah.
I
So
think it is waiting for.
it's already get 45. That means you will get exactly the same result anyway.
Yeah, yeah. It definitely takes longer. The
Yeah,
GRG
yeah.
nonlinear just like took probably 1 second.
Yes, but evolutionary can handle the initial value problems.
Oh, there you go.
Okay.
Mm,
Okay.
yeah, it's
So you
nice.
can try using evolutionary, but all one, for example. Okay.
Like this one.
No, no, the flow, the initial value of
Oh,
the one that a while ago. If you use GRG all one, for example, in the flow, it doesn't solve.
oh, like I put one here.
Yes, initial value.
Oh, it doesn't take initial value.
It, that is initial value.
Oh, I mean, like the GRG nonlinear doesn't take initial value,
The
right?
one that you put as changing variable cell, those are the initial values.
Yeah. Okay.
Okay. So if you try using a GRG nonlinear, it doesn't work. You try.
Hmm.
Hmm.
Yeah, it doesn't work.
Doesn't work, right?
Or could not
Could not find,
find a
right?
possible solution. Yeah.
Yes, cannot find. But you can try using evolutionary.
Okay. Evolutionary. So
Yes.
might take a little bit
Yeah,
longer.
it will take a while, but it's supposed to work because evolutionary is supposed to work even if it will go out from the local optima.
Oh, so evolutionary is not looking for local optima.
It,
So it's looking for the real
global.
optima.
Yes, evolutionary is looking for global optima
Okay.
because it generates randomly. Okay, so it will put anywhere in that domain.
Mm.
Okay. So if it doesn't work, meaning you probably set the domain wrong.
Oh yeah, it works.
Yeah, it works,
Oh,
right? Using
okay.
evolutionary will make it work. Why? Because as long as it is in the domain, you can set the domain, right? You go to the option of evolutionary, then you can set the minimum and maximum there. Okay.
Yeah, it works.
Yeah, it works. Okay. So GRG not always work, and GRG is always sensitive to the initial values. Okay. GRG means gradient method.
Mm. Oh, that's why in the assignment we have to use evolutionary like assignment last week
Correct, correct.
because the order is already filled. Yeah. Okay.
Yes. Okay. So if you use GRG, it will not work.
Yes.
Okay. And evolutionary is also if you have discrete values. Okay. Remember, Newton method uh, assume the function is continuous. Remember, Newton method, you need to take derivative,
Yeah.
right? Okay. And then that derivative was approached using second method. Remember?
Mm-hmm.
So that is the basic of GRG. Okay. Uh, Basically, I will share my whiteboard. Okay. So you have like this, yeah. So uh, what you will do is I will. Oh, what happened? Okay. So suppose this is your curve, and you want to find the maximum, right? Then you start here, example. So using GRG method, what you will do is you find the gradient, or using Newton-Raphson, right? You find the gradient, right? If you if you look at the Newton-Raphson, it's exactly this. You start with initial value. Here you find the gradient. The gradient is the derivative, right? And then you check this one and this point. Which one is higher? Oh, this is higher. So you go here. And then again, you set the gradient here. Okay. Until it will go up, climbing. So this is called hill climbing method. Okay. Hill climb. Okay. So eventually in here, you will find this place here, which has what? The gradient of 0, right? You know from calculus, when the gradient is 0, that means that is the optimum, right? So then it will stop. So usually, if your delta, the change, okay, is very large, it will not reach that exact point. It will go back and forth around the optimum value. Okay. So then you need to change the delta so that it becomes smaller and smaller. Otherwise, it will not convert to that optimum value. So that's the method of gradient method. So GRG is basically gradient method. Now, what happens if you use evolutionary? Yeah? The evolutionary can be genetic algorithm, can be PCO, can be an optimization, right? So the basic idea is instead of from one point, right? So then the idea is to create many points randomly, right? And then from this point, going down here, many points, okay? From this many point, and then search the next other point. So it's using many points. Every time it's using many points. Searching using many points. That's why it takes longer to search, right? But finding global optima is more likely than the gradient method a while ago. So from here, you get this point, then you find another point which is in here jumping, and then from here probably going back to there, and then going back here, and then going probably there, going back. Finally, you will eventually find that optimum within the searching period. For example, it's really complex. It will not find the actual optimum value, but it's close. So that's how the evolutionary method works. I hope this is clear. Oh, Livy, can you share your screen about the shortest path? Oh, super. It works, right? Yes. Okay, now I want to give you one more lesson about maximum entropy. Can you open the slide of maximum entropy? Okay.
Sir, is it maximum flow?
Oh, maximum entropy.
Oh, wait.
Maximum flow you want, or you want maximum entropy? I think
Where is maximum? Oh, the number 38. Okay.
number 38, yes. Maximum flow is very similar to shortest path. I can brief you about that in a moment. But I think for your knowledge, to broaden your knowledge, right? So I think it's better discuss about maximum entropy first because this is very important method. Okay. So let's say I open my Excel. Huh? Okay, so I will share my screen with you. So suppose I have how many you want? 5, 4. Okay, let's make this as our slot. Okay, so I will put it A, B, C, D, E. Okay, let's name it. Okay, and then let's keep any number you want, whatever number you want. 2, 3, 4, 5, 2. Is that okay? If you don't like, you can change that, no problem. So now I have the sum in here, which is the sum of this one, right? And then I have the average here. Average. Okay, I will put it here. Average. Oh, average. Okay, and then average, right? Okay, average. Oh, 3.2. My question is this. Okay, this is random number. You can change any number. My question is this. Suppose I fix these numbers. Okay, look at this. Now I delete this number. Hey, you remember this one is 16 and 33.2, right? So I will paste and value here, huh? So that you will remember this, huh? So I've deleted this yellow cell here. Ta-da! Yeah. My question to you, what is the value in E so that the sum will be 16 or the average will be 3.2? Very easy, right?
2, yeah.
Of course. Huh? 2. Right, 2. There, okay. Very good, right? So, okay. This is what I want to into why I answer this. Given the statistics, do you know what's the statistic here? The sum, the average, right? Given the statistic, okay, now you have a missing data, okay? How many missing data that you can recover? Given the statistic, how many missing data that you can recover? That is called degree of freedom. DF, degree of freedom. Okay? Given the statistic, sum, average, how many missing data that you can recover? For example, okay, I will have a table something like this. Okay, this is the same table. You can fill up with any number. 1, 2, 3, 4, 5, 3, 6, 7. Okay? So then I'll take the sum here. The sum is 31, right? Okay, I will put it 31 here. So how many data that I can delete in this 2 by 2 table? What is the degree of freedom of this table? So given the statistic, which is 31, okay, how many data that I can delete here so that I can recover? Okay, so the DF of any table, I will tell you that the DF of any table is equal to the number of rows minus 1 multiplied by the number of columns minus 1. So how many rows here? 4 rows, right? So that means 4 minus 1 multiplied by how many columns? 2 columns, right? So then 2 minus 1. Okay, so then I multiply 3 multiplied by 1, I get 3. So I can delete 3 in here, any. Okay, for example, I delete this value, I delete this value, and I delete that value. I can still recover. Okay, look, I recover this. Can you recover this or not? I randomly delete. Can you recover that the sum must be 31, not 23? Okay. A while ago, 1, 4, how many is this? 3. Right. So I will put the sum here so that you will see also. Oops. Why? Okay, so this is the sum. Okay, so this is 16, this is 15. So I will move this out there. This is supposed to be 3, 7, 8, 13. Okay, so now I delete this one. Then you know this is supposed to be 15, right? But now only 12. So what is missing here? You see here, this is what is supposed. Okay, this is what is supposed. Okay, so I know it should be 15. This is, I will create this as a green so that you know. Okay, this sum of column must be 15, but we are missing 1 in here. So what is that missing value? 3, right? Because now it's 12, so then this must be 3. Then how about this one? This is supposed to be 3, but you know this is now on 2. So what is this value? What is this value? In D7, what is the value?
Well, it depends on the other one, right? Because there are 2 empty shells.
No, not depend on the other one. Look at this column. Look at this row. We know that this sum must be 3, but now the sum is 2. Then this one must be?
Oh, 1.
Yeah, exactly.
Oh, yeah.
Okay, then you know that this is should be 16, and this one must be 7 total, right? But here is 12, so what is the number in here?
4.
Exactly, so 4, right? So given the statistic, okay, this is the statistic, right? The one in green, okay? The one in green here are the statistics, okay? How many missing values I can put in, okay, so that I can recover. Okay, this is called degree of freedom. Is it clear or not? The concept of degree of freedom first. Clear? Livy, is it clear or not clear? Okay, tell me what is degree of freedom in here.
So the degree of freedom is how much you can change a shell, a cell with some constraints that For example, this one, the sum have to be 16 and
Correct.
the sum on the row has to be 3. Yeah.
Correct. Okay. Now, degree of freedom in array is just df in array. Okay. Is just n minus 1. Okay. N in here is 5, right? So, oh, df is basically only 1. Sorry. The df is 1. Okay. The df is 1. So that you can get the total that you need to have in the data must be n minus 1. Okay? The df is always 1 in here, in array. And then in the table is number of row minus 1, number of column minus 1. Okay? Now, okay, I will delete this table first, so that you will not get confused. Okay, what will happen if instead of one cell, I make two cells which is beyond the df? I make two cells that is missing. Ta-da. Can you recover? Can you recover that D and E? What is the value of D and E in here? So that the sum is 16 and the average is 3.2, or the average is 3.2. What would be the value of D and E? Okay. So that the sum is 16. This is go beyond the degree of freedom. If you have the degree of freedom, okay, only one cell, right, in this case, of course, you can just do manually, right? How about if you have more than the degree of freedom? The missing value is more than the degree of freedom. How do you recover your data?
Actually, probably you cannot, right? Because the
Cannot,
missing
correct?
value, yeah, the missing value is larger than the degree
Yes.
of freedom.
Okay, so you cannot recover your data. Okay, the original data you cannot recover, correct? Okay, but how are you going to fill in so that the sum is 16? Forget about the average. So that the sum in here is 16. Suppose you don't know, okay? The original data you don't know. What value I should put here so that the total is 16? Livy, if you don't know anything, I have a cell of 5 cells, right? I have 5 cells here. Oh, okay. I have this 5 cell, and I have 2 missing values, and I know the sum is 16, not 9. So what is D and E? What is the most probable value of D and E? You don't know anything about the original data.
Considering we want the sum to be 16.
Yeah, I just want the sum must be 16. I just want the sum, not 9, but 16.
So we can take any number?
Yeah, you can take any number. What is the number? Example.
4.
4, you want to put 4 in here. And then what is this number in here? 3.
4 and 3, 3.
3, right? Oh, 4 and 3, that's correct. I can take 1 in here. And then I can take 3 plus 3, so 6 here, correct? Oh, that is also sum of 16. But when you take 4 and 3 here, right? Correct, the sum is 16, right? But is this, when you put 4 and 3 here, how are you going to explain that this is 4 and 3? Why not 3 and 4? Is this more likely? Other people will argue about it, right? So what is the more likely value if you don't know anything? What assumption you will take so that people will not argue with you? Because if you put, oh, I want to put 1 and 6 here, okay? And then Pancha said, no, 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 this is should be 4 and 3. Okay? Maybe Joy will say, no, this is should be 5 and 2. Everyone will have their own idea, okay? But each of this idea assume something, right? When you said 2 and 5, you already decide that D must be lower than E, right? When you said, no, this is 4 and 3, you already decided, assumption behind your mind, that D must be larger than E. Okay? Then the question is, what is the basis of your assumption? Right. So, if you assume nothing, what will be the value here? That's the good question. More likely, you will say, okay, then I assume equal, correct? So that is 3.5 and 3.5. Correct or not? 3.5 and 3.5. So then the question is, why you assume equal? Right? Because by assuming equal, yeah, this is called uniform distribution, right? So basically you assume nothing in here because you don't say that D is larger than E or E is larger than D. Okay, you just make your maximum doubt, right? So I will draw. How do you draw a whiteboard? Okay. So I will put this as a probability. Okay, and this is doubt. Oops. Your doubt. Okay. You doubt about it, and the drawing is something like this. Suppose you have only 2 chances. So the probability of 0 is certainty. Right? Certainty will not happen. Okay? The probability of 1 is also another certainty, will not happen. Right? So then the probability of half, if you have only 2 coins, head and tail, okay, that is the maximum doubt. Why? Because you are not sure when you toss a coin, it will be head or tail, right? Yeah. Now, if you have 3 values, for example, going up, down, or stay, okay, in the stock market, then the probability of maximum doubt will be 1/3, right? Yeah. If you have a dice, okay, which have 6, yeah, the dice you have 6 faces, right? Okay. So the dice have 6 faces, then the probability of maximum doubt will be 1/6. Meaning that the uniform distribution is the maximum doubt. Okay. In your case here, okay, so in your case, in this Excel a while ago, so you have, this is the probability, is only 2 possible values here, then the probability will be 0.5 and 0.5. Correct? So what will happen now? I will change again. Okay? What will happen, instead of 2, now you have 3. Three missing values. What will be the value in here so that the total will be 16?
So it will probably 16 minus 5 divided by 3.
Very good, right? That will be 16 minus 5 divided by 3, right? And I copy this. Yes, because this one now become, the probability is 1/3, right? Correct? How about if I have, instead of 3, now I have 4 missing values? Is it possible? This is go beyond the DF, right? So what is the value here?
Well, again, 16 minus 2
16
divided by
minus
4.
2 divided by 4, right? So that the probability becomes 0.25. Huh? How about if I have all, everything is empty, okay? I have 5 empty slot, okay? And I want the sum will be 16. What will be the value? Okay. Then you will say, okay, 16 minus 0 divided by 5, right? So that the probability will be 0.2, right? Correct, huh? So that means this is 16 divided by 5. Yeah? So this is what is common sense, isn't it? If you don't know, okay, if you don't know, then you assume equal. Correct. That common sense is like that, okay? When you don't know, you assume equal. That is why, because you maximize your doubt. That means you don't assume anything. Basically, you maximize your doubt, right? It's the most uncertain things. Because you don't know, then you assume equal. Why is assume equal? Because you maximize your doubt. By doing maximize your doubt, you are sure this is the most uncertain. Okay? So now, in more complex problem, okay, this is very simple problem, right? You only have the sum, right? How about if I, instead of sum, I have average? How about instead of average, I have standard deviation, for example? Right? The statistic is not the sum, but the standard deviation. So how are we going to set? Okay, how are we going to set the value here so that given the statistics, I want to recover the values of the missing value, of the missing slot?
So far.
Yes, how are you going to solve?
So we find the of course we set the the value that we want to find first, right? Like
Okay,
if
okay.
we want the standard deviation to be 3, for example,
Yes.
right? And then we put in the formula for standard deviation, and then we use solver to change the variable a b c to e, so that the formula can be equal to the value that we want.
Okay. Okay. You can try that. Okay. You can try that. Okay. Let's try. Okay. 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 Let's give this. How many missing value you want? 2, 3, or all?
3 maybe.
Okay. Let's make 3. Okay. So that. Oh no, 3. So that means you know 2, right?
Yes.
So let's make this 2 is given. So let's give this. This is this is 4 and 5. Okay. And we know this must be 16 minus 9, correct? Divided by 3, right? Should be, this is the answer, right?
Yes.
Yes. Okay. So, but we don't know now. Okay. So, I will just give this as 0, 0, 0 as initial value. Okay. You try using solver. It's supposed to give you the value that you want, which is 2 point something, 2.3. Okay. Okay, when you make it, you share your screen. Okay.
Sir, we still use the sum, not the.
Oh, okay, okay. At this point, some later we will improve using
Okay.
average or something else.
16.
This is fun because now you can recover data. In fact, you can create data. Okay. Suppose you don't know the data, you have missing values. So what are you going to fill in?
I can share my screen.
Cool.
So this is all right. We can set it to 0 first.
Mm-hmm.
And we want 16, but our sum is still 9. So we go to solver, select this value of 16 by changing variable this one, right? This is, yeah, okay. And then, yeah, there is no constraint. So the
Okay.
constraint is already value of 16.
Okay.
So, yep. So we just solve it, and then it will get 2.3336. Yeah.
Very good. Very good. Right. So now what will happen if the instead of, okay, now you can put any numbers there initially, not 2.3,
Oh.
simple 1, 2, 3 if you want. Oh, pulang. You get maybe 3, so that the total is 16.
Oh, so the total is 16. Okay.
3.
Ooh.
Okay, okay. So now get the average. The average of all. No.
Yes.
Okay, 3.2. Okay. Now we want to get 3.2.
Okay, so we want 3.2,
Mm-mm.
but this is still divided by, oh, sorry.
You just take
It's just
average,
5.
equal average is the same.
Oh, yeah, this is the same. So
Okay, using solver. Mm-mm.
yeah, we can get it as well, right? We
Mm-mm.
just change it into this one,
Mm-hmm.
value of 3.2. Oh, oh, hold on. Wait, where's my,
Set
oh,
objective.
3.2 by
Mm-hmm.
changing variable there. Okay.
Mm-hmm. Okay. This is using evolutionary.
Oh, you cannot see my solver. Oh yeah, I should have shared the
Yeah,
whole
it's okay.
desktop. Okay.
Yeah, yeah. So good. Now you get exactly the same result, right?
Yeah.
Uh-huh. So uh, the same thing. Okay. Now you start to get the standard deviation. Okay. So now you change this. This is more challenge now. So you can change this to 1, 2, 16 minus 9 is 7. So then 1, 2, 4. Is that correct? Okay, CDE, try to make it 1 to 4 originally. Or 4 to 1 is up to you. CDE, instead of equal, so can you make it not equal originally?
CD. Oh, okay. 4.
4 to 1.
Okay.
Okay, and then take the standard deviation. Equal SDEF.
Let me just
STD. STD.
STD. Yeah.
STD. Okay. Oh, that 5. Okay, close it. Okay, that copy value there.
All
Oh,
right.
all right. So then now you delete the C, D, and E. Oh, no, that one.
Oh, yeah. Sorry. Yeah, this one.
Yeah, that one. Okay, now you solve it again. Try to recover the standard deviation.
This one. Value of,
That one. 1.6. Or maybe you copy the.
yeah, maybe. Wait.
Okay. That one. On the top, you can copy.
Yeah, value of. Oh, you cannot paste on solver. Oh, okay. Then 1.64.
Okay,
1,
close is okay.
6, 7.
6, 7.
Oh,
Okay. Solve.
so oh oh because it's a standard deviation that we want,
Right.
but the average will be different.
Right.
We forget the constraint.
Okay. Then you add the constraint,
Yeah.
uh, the mean.
Solver add
Ah, that the sum.
this has to
No,
be
no, no, the
equal.
sum only.
Oh,
Only the
okay.
sum.
Solve.
At certain point, solver cannot solve it. Okay? If you put too much concept.
Oh yeah, could not find a feasible solution.
Right.
Hmm.
Right. Okay, so there is another method, okay, which is similar to this one, okay, that you can use if you want. Okay. No guarantee that solver can solve it, but there is another method which is called maximum entropy. So what is maximum entropy? The one that we discussed a while ago, okay, the one in the whiteboard. Maximum entropy mean what? That is meaning maximum doubt. Okay. So when you put maximum doubt, that is the doubt here, this is the uncertainty, right? Okay. The doubt means maximum uncertainty. So how do you measure uncertainty? That is called entropy. Okay. So entropy is basically the way to measure uncertainty. So what is the formula of entropy? Right. So I will clean up this one. Suppose you have the probability. Okay. If you want to get the entropy, then you multiply that probability, for example, pi, okay, with the ln or the log of pi. Okay. But the ln of pi will be negative, so you put it negative. And then you sum for all I. So this is called entropy. Okay. So let's do that for our problem here. I will solve this. Okay. So what I will do is I calculate the probability. Right? What is the probability here? Probability is the value divided by the sum, isn't it? Right? So that value I divide by the sum, so that I can copy, I put $sign here. So these are the probability. You know the sum, okay, of the probability is always 1. Right? And then I will calculate what is called entropy part. Okay, so entropy part is each of this probability, okay, if the probability is larger than 0, okay, then I will calculate that probability minus that probability multiplied by the ln of that probability. Okay. Otherwise, 0. Right? If 0 or less than 0, then you put it as 0. Okay, then you copy, and then now you calculate the entropy. The entropy is just the sum of the entropy part. Okay, so this is the entropy that you want to maximize. So now what you will do is you create a solver, right? You want to maximize that entropy. So I will name this entropy. Okay, so maximize the entropy by changing what cell? This is the 3 cell that we want to change. Subject to constraint. Okay, what is the constraint that we want? Okay, of course, we want that, for example, the sum here must be equal to this one, right? Okay, and then of course you want to add that the sum of the probability must be 1, yeah? Okay, and then you solve. You find the solution, this one. Is it clear? Easy, right? So now if you say, oh, I don't want the sum, I want the, what is that? The average, right? The average is average of this one, right? So the average is 3.2, okay? So 3.2. Okay. Now I can change this. What do you want to change? Now I change the cell of this one must be the same as this one, right? Of course, this is already solved, okay? So let's say if you solve it, the same result. Now let's say I have a 0, 0, 0 or 1, 1, 1. It's okay. Okay. Now I solve this. Oh, what happened? I do not find the solution. If I try with the 0, 0, 0, oh, I found the solution with this the same. Okay, 2.3. Okay, so you can also do the same thing. For example, if I want to get the standard deviation, right? So a while ago we said, okay, the standard deviation is 4, 1, what is the 3? Is that no? 2. Okay, the standard deviation STD is standard deviation of population. Suppose this is the one. Okay, 1.4. Is that so? So I copy this. I put it as base value. Okay. So now I make it 0. Right? Again, the same, huh? So we want to do the solver, okay, by changing it so that the standard deviation, okay, is equal to that value, right? So then you solve it. Oh, find the solution again. But this is the sum is no longer 16, so you can add one more constraint, right? What is the constraint? I want the sum must be equal to 16, and then try to solve it. Cannot find solution also, then we can try using try non-negative. Still cannot find, then we try to use evolutionary. Okay, we try to use evolutionary. Okay. The point is you can solve using maximum entropy. Okay. How to calculate the maximum entropy? You sum, okay, and then you get the probability, and then you calculate the entropy part, and then you calculate the entropy, and then you use solver to solve that. Oh, still cannot find the solution. If you have too much constraint, you cannot find also the same. Yeah. So this is another method if you want to use, okay, to get the maximum doubt, okay, which is the maximum uncertainty. Okay. Okay. Thank you for today. you have amazing project, right? This is very ambitious, very good. Okay, so hopefully you can finish before the final exam. Do you know the date of the final exam already?
I think next week is the last meeting.
Correct. So next week we will discuss about briefly about macro.
Yeah, and our final exam, like the spreadsheet one. Wait, oh,
Do we ready? If we know, I will record it here. If not,
spreadsheet one on 6th December, December 6th,
December 6th,
Monday. Yeah,
Monday.
at 9. Monday. Yeah,
Okay, at 9
at 9 a.m.
until
until 11.
11. So you want to do it in Moodle or you want to do it in Google Classroom?
I think Moodle is better so that you can actually pick if the answer are there are two answers, then
Yeah,
you
yeah,
can
yeah.
pick one.
Okay, in Moodle. You are very special. All my other classes are in Google Classroom. Okay, I will open it in Moodle. So I really enjoy this semester with you. Okay, you you really are amazing students. Okay, thank you very much. So for today, so see you next week. I think I already posted several, one or two slides maybe in Google Classroom about macro. Is it?
Um, I haven't checked.
Let me check also.
Oh yeah, there are two slides about
Two
macro.
slides. Okay, so these are the very basic one. Okay, so I'm not sure. You tell me, okay, if this is too easy, you tell me I can go beyond this, okay? Because I thought you only one. Oh
Oh
no,
yeah, only one, sir.
only one,
One
only
is
one.
website. One is
Oh,
the
okay, only one.
link. Yeah.
Okay. So anyway, this is Excel macro. Oh, what do I have here? Oh, this is the simple text box, click games. Tell me if this is too easy, okay? Then we can go beyond this if you think this is too easy. Okay. This is like very basic anyway. So if you don't tell me anything, I will go with that. But if you want more, you tell me beforehand, then I will prepare for you. Okay.
Okay, sir.
Tell me during the time. I cannot prepare at one moment. I'm not genie. Okay. So tell me probably today or tomorrow. You can WhatsApp me and then I can prepare. Okay. But if this is you think this is enough, then I will discuss this. Okay. So
Okay, sir.
the one uh, in my tutorial in Visual Basic, that is the old one, but I think that is still working. Yeah. So yeah, I think that exact exactly the same. Yeah. The what is that called? Excel is basically the same as Visual Basic 6.
Yes, they just
Okay.
poured it into Excel.
Yes. Okay. So that is the very old basic. The new one is Visual Basic Net is not the same anymore. Okay. So okay. So thank you very much.
Okay, thank you, sir. See you next week.
See you next week.
Okay, thank you, sir.